Problems based on triangles. First one in figure, angle ADE equals to angle B. Show that triangle ADE similar to triangle ABC. If AD equals to 3.8 centimeters, AE equals to 3.6 centimeters, BE equals to 2.1 centimeters, and BC equals to 4.2 centimeters. Find the solution. Let's get the figure. Triangle ABC, right angle at C. This is the angle D. A here where this line intersect. Now given AD equals to 3.8 centimeters, AE equals to 3.6 centimeters, BE equals to 2.1 centimeters, BC equals to 4.2 centimeters. Now he asked to find the value of the solution. Consider triangle ADE and ABC. That means triangle ADE and whole triangle ABC. Angle ADE equals to angle B. He given angle AD is equals to angle B. This is a given thing. Next, angle A is common in both triangles. Angle A is common, therefore triangle AD congruent to triangle ABC. Both triangles are congruent now. Then the sides may be proportion. Now AD by so AD is the side of the smallest triangle which is opposite to angle E. Here angle C and angle E are equal, so I have to take the side opposite to angle C, because corresponding sides means sides opposite to equal angles. So AD by AB equals to DE, which is opposite to angle A, and BC is opposite to angle A. I can write AD by AB as AE plus AB. I can split AE plus EB, that is equals to DE by BC. Substitute the values. AD 3.8, 3.6 plus 2.1, that equals to DE by 4.2. Then you will get 3.8 by 5.7 equals to DE by 4.2. DE by 4.2. 1.92s, 1.93s. Then DE equals to 2 into 4.2 by 3. Bring this to 7. Then 3 ones, 1 remain, 1.2, that means 0.4. That equals to 2.8 centimeters. Finished. Now second question in figure. If QT by PR equals to QR by QS and angle 1 equals to angle 2, prove that triangle PQS similar to triangle TQR. Let me get the figure first. So this is the triangle PQR and RT is the one which extended and things parallel to SPS. Now see once. Solution. Given that QT by PR equals to QR by QT by PR equals to QR by QS. From this I can write QT by QR equals to PR by QS. Yes. Also we have angle 1 equals to angle 2. This is the angle 1, this is angle 2. Angle 1 equals to angle 2. So these two angles are equal, then sides opposite to the equal angles are equal. That means from this you can write PQ equals to PR. PQ equals to PR. From this I can substitute PR as PQ. That means QT by QR equals to QT by QR equals to QT by QR equals to in the place of PR keep PQ. PQ by QS. Now I can write this as PQ by bringing Q to this side. PQ by QT equals to PQ by QT equals to QS by QR. Thus in triangle PQS, triangle TQR, QS equals TQR equals TQR PQ by QT equals to QS by QR, and angle 1 is common. See, PQ by QT, QS by QR, sides are in proportion and angle between them is equal. Therefore triangle PQS similar to triangle TQR by SAS congruency. So by SAS similarity rule. Going for the next question. Now third one, P and Q are points on sides AB and AC respectively of triangle ABC. If AP equals to 3 centimeters, PB equals to 6 centimeters, AQ equals to 5 centimeters, and QC equals to 10 centimeters, show that BC equals to 3 PQ. This is a triangle ABC. P is point on AB and Q is point on AC. Solution. We have AB equals to AP plus PB. That means 3 plus 6 equals 9 centimeters. We observe that he given AP 3 centimeters, PB 6 centimeters, AQ 5 centimeters, QC 10 centimeters. That means total 9, here total 15 centimeters. That QC equals to AQ plus QC, that equals to 5 plus 10, 15 centimeters. Now AP by AB equals to AP by AB equals to 3 by 9, 1 by 3. Let it be. AQ by AC equals to 5 by 15. That be 1 by 3. That means AP by AB equals to AQ by AC. Let it be 1. Consider triangle APQ and triangle ABC, whole triangle ABC. AP by AB equals to AQ by AC from 1, and angle A is common for APQ triangle and ABC triangle. Angle A is common. Now two sides triangle are proportional to the other two sides of triangle. Angle within them is equal, therefore those triangles must be similar. Therefore triangle APQ similar to triangle ABC. So two triangles are similar, all sides are in proportion. That means AP by AB equals to PQ by BC equals to AQ by AC. Now PQ by BC equals to AQ by AC. Observe here, AQ by AC is nothing but 1 by 3. That means PQ by BC equals to 1 by 3. From the second right, BC equals to cross multiplication 3 PQ. Hence we proved. Problems based on triangles. First one, in an equilateral triangle, ABC the side BC is trisected at D. Prove that 9 AD square equals to 7 AB square. Solution. Where ABC is equilateral triangle, BC is trisected by BD. That means BD equals to 1 by 3 BC. Solution. ABC is an equilateral triangle in which BD equals to 1 by 3 BC, because that is a trisection point. Now draw AL perpendicular to BC. AL perpendicular to BC. Now consider triangle, and moreover, since it is equilateral triangle, AB equals to BC equals to AC, all sides are equal. Let it be equation 1. Consider triangle ABE and AEC. Angle BEA equals to angle CEA. Both are 90 degrees here, because AL is perpendicular to BC since, and AE is common, and AB equals to AC from 1, because it is an equilateral triangle, all sides are equal. Therefore triangle ABE equals to, triangle ABE congruent to triangle AEC by RHS criterion. by RHS criterion. Two triangles are congruent. BE equals to EC. Let it be equation 2. BE equals to EC. Let it be equation 2. Then from this I can write BE equals to half BC, because BE equal to EC means E is the midpoint, so BE is half of the BC. Let it be equation 2. Now consider triangle ADE. We can write AE square equals to AD square minus DE square. In triangle ADE, right angle, so hypotenuse square minus side square gives AE square. Let it be 3. Now consider triangle ABE. AE square equals to AB square minus BE square. Equation 4, because in ABE triangle AB is hypotenuse, so AE square should be the hypotenuse square minus remaining side square. Now if you observe 3 and 4, LHS are equal, so I can equate the RHS. That means AB square minus, otherwise first mirror, AD square minus BE square equals to AB square minus BE square. Now AD square, let it be like this, because we have to prove AD AB, so AB and AD don't change. Now DE, if you observe that DE can be written as BE minus BD. BE minus BD whole square equals to AB square minus BE square. Now AD square, in the place of BE I can write half BC from 2, half BC, and BD from the given 1 by 3 BC whole square minus AB square minus, again BE equals to half BC whole square. Now AD square minus LCM is 6, so 3 BC minus 2 BC, I'm taking the LCM, whole square equals to AB square minus half BC whole square. Now AD square minus 3 BC minus 2 BC, BC by 6 whole square equals to AB square minus half BC square. Now the place of BC, again I am writing AB from equation 1, so AD square minus AB by 6 whole square equals to AB square minus AB by 2 whole square. That means AD square equals to AB square minus AB square by 4, if you bring this side, plus AB square by 36. Then AD square equals to, take 36 LCM, so 36 AB square minus 4 9s, 9 AB square plus AB square. Bring 36 this side, 36 AD square equals to 36 plus 1, 37, 37 minus 9, 27 AB square, 28 AB square. So 4 9s, 4 7s, you will get 9 AD square equals to 7 AB square. There is a thing we have to prove. Going for the next problem. Problem number 2. P and Q are midpoints of the sides CA and CB respectively of triangle ABC. Right angled let's see. Now prove that. First one, 4 AQ square equals to 4 AC square plus BC square. Second thing, 4 BP square equals to 4 BC square plus AC square. Third one, 4 AQ square plus BP square equals to 5AB square. Now that ABC is a triangle, right angle, let's see. P and Q are the midpoints. P and Q are the midpoints. Now solution. Let me get the first one. Consider triangle AQC. AQC. I can write hypotenuse square AQ square equals to AC square plus QC square. AQ square equals side square. AQ is hypotenuse here. Hypotenuse square equals to side square plus side square. Now I'm multiplying with 4. 4 AQ square equals to 4 AC square plus 4 QC square. Now I can write this as 4 AQ square equals to 4 AC square plus 2 QC square, and 4 AQ square equals to 4 AC square plus 2 QC. Since he given that Q is midpoint of BC, 2 QC is nothing but BC. So in the place of 2 QC I am writing BC. So hence first thing is proved, and let it be 1. Now second, consider triangle BPC. BPC, hypotenuse is BP, so BP square equals to PC square plus BC square. So I'm multiplying with 4. 4 BP square equals to 4 BC square plus 4 PC square. Again 4 BP square equals to 4 BC square plus, I'm writing this as 2 PC whole square. Now 4 BP square equals to 4 BC square plus 2 PC. Since P is the midpoint he given, 2 PC is PC plus PC, that means PC plus AP, which is nothing but AC, because these two are equal. 2 PC means PC plus PC, that is nothing but AP square, sorry, AC square. AC square. Now add third one, add 1 and equation 1 and 2. Left side will get 4AQ square plus 4BP square equals to 4AC square plus BC square plus 4BC square plus AC square. If you observe this, you can take 4 common. 4 into AQ square plus BP square equals to 4 AC square, AC square, 5 AC square, BC 4 BC square plus BC square, 5 BC square. I can take 5 common. AC square plus BC square. If you observe this, AC square plus BC square is nothing but hypotenuse square AB square. So 5 into AB square. This is we have to prove. Next question. The hypotenuse of a right triangle is 6 meters more than the twice of the shortest side if the third side is 2 meters less than hypotenuse Find the sides of a triangle. So in right angle triangle, one will be the short, hypotenuse is the longest. Now let shortest side equals to x. Hypotenuse is 6 meters more than twice the shortest side. That means twice means 2x plus 6. Now third side equals to 2 meters less than the hypotenuse. That means 2x plus 6 minus 2. That means 2x plus 4. Now by Pythagoras theorem I can write 2x plus 6 whole square equals to side square plus side square. That means x square plus 2x plus 4 whole square. Then we will get a square 4x square plus 36 2ab 2 2s are 4 4 6 24 x, that equals to x square plus a plus b whole square, again 4x square plus 16 plus 2ab 2 2s are 4 8 8 2s are 16 4 2s are 8 8 16x 4x square cancel. Now x square plus 16x, bring this side, minus 24x plus 16 minus 36 equals to 0. Then x square plus 16 minus 24 minus 8x plus 16 minus 36 minus 20 equals to 0. Or splitting method, I can write this as minus 10x plus 2x minus 20. Minus 10 into plus 2 minus 20 minus 10 plus 2 minus 8. Okay, can take x common, x minus 10. Here 2 common, x minus 10. Though I'm taking x minus 10 common, x plus 2 equals to 0. From this either x equals to 10 or x equals to minus 2. So this is the side, it is not possible, therefore x equals to 10, that is shortest side equal to 10. Then hypotenuse equals to 2 into 10 plus 6, that means 26. Third side, remaining side equals to 2 into 10 plus 4, 24. End of this. Problems based on triangle. First one, in figure ABCD is a trapezium with AB parallel to DC. If triangle AED similar to triangle BEC, prove that AD equals to BC. ABCD is a trapezium given AB parallel to DC, and these two triangles are similar. Then we have to prove these two sides are equal. Solution: triangle EDC and EBA. So this is the point EDC and EBA. Angle 1 equals to angle 2, alternate angles. Angle 3 equals to angle 4, again alternate angles. These two angles are equal, vertically opposite angles. So angle 1 equals to, from figure, angle 1 is equal to angle 3 equals to 4, because alternative angles, since these two are parallel, it acts as a transversal, these two angles are equal, internal alternate angles. And AB DC acts as parallel lines, DB acts as a transversal. 2 and 4 are equal, so 1 and 2 are equal. Alternative angles, same thing. Angle AOB equals to, angle AEB equals to angle DEC. because VOA vertically opposite angles. Now therefore triangle EDC similar to triangle EVA. Now I can write the sides in proportional. ED by EC equals to ED by EB, sorry, ED by EB equals to ED by EB equals to sides opposite to same angles 3 and 4. EC by EA, EC by EA. From this I can write ED by EC equals to EB by EA by cross multiplication. I am bringing EC this side, EB that side. Okay. Now it is given that triangle AED is this triangle AED similar to triangle BEC. So these two triangles are similar means I can write them as ED by EC equals to EA by EB that equals to AD by BC, because he given AED triangle is similar to BEC. Let it be 1, this be 2. From 1 and 2, ED by AC equals to EB by equal to AD by BC. That can I write now EB by EA equals to EA by EB. EA by EB. Gross multiplication. EB square equals to EA square. Taking square root on both sides will get EB equals to EA. Now EB equals to EA, substitute in 2. Now 3 in 1, substituting 3 in second equation. This is EB. ED by EC equals to EA by EB equals to AD by BC. I am substituting here EA in place of EB. Now I will get EA by EA equals to AD by BC. From this I can write AD equals to BC because 1 1 and it's proved. Through the midpoint M of the side CD of a parallelogram ABCD, the line BM is drawn intersecting AC in L and AD produced in E. Prove that EL equals to 2BL. Now solution. Now ABCD is a parallelogram. ABCD is a parallelogram. So here M is the midpoint and BM is produced to meet AD at E. This is the given information and M is the midpoint. Solution. In triangle BMC and a triangle EMD, that means BMC, this triangle vertical opposite angles are equal and MC equals to MD because M is the midpoint given. MC equals to MD since M is midpoint. Angle CMD equals to angle EMD, VOA vertically opposite angles, angle MBC equals to angle MED, alternate angles. Since AD parallel to BC, in parallelogram opposite sides are parallel, so two parallel lines and alternative, these two angles are equal. Therefore triangle BMC congruent to triangle EMD by angle side congruency. Therefore BC equals to DE, BC equals to DE by CPCT. And we know that AD equals to BC, AD equals to BC, since opposite sides in parallelogram, opposite sides in parallelogram. Now AD equal to BC. Now I'm adding AD plus DE, nothing but AD plus DE, that equals to BC. In the place of DE again I am writing BC, BC plus BC. AD plus DE equals to AE, that equals to 2BC. Let it be equation 1. Now consider triangle AEL and triangle CBL. This is L, ABL and CBL. Sorry, AEL, AEL, these two triangles. Angle ALE equals to angle CLB, VOA vertically opposite angle, these two angles are equal. Angle EAL equals to angle BCL, EAL equals to BCL, these two angles are equal because alternate angles. Therefore I can say that triangle AEL similar to triangle CBL by AA criterion. Now I can write EL by BL equals to AE by CB because if two triangles are similar, the corresponding sides are in proportion. Now EL by BL equals to AE, nothing but 2BC from 1, 2BC by BC, CB are nothing but BC. Substituting 1 here, BC get cancelled, then EL equals to 2BL. Hence the required ring is proved. Next problem. Two isosceles triangles have equal vertical angles and their areas are in the ratio 16:25. Find the ratio of their corresponding heights. Now let ABC is isosceles triangle and DEF is one more isosceles triangle. AL is the height here and DM is the height for this, that means altitudes for both the triangles AL and AM. Solution: given area of triangle ABC by area of triangle DEF equals to 16 by 25. Take draw AL now draw AL perpendicular to BC, DM perpendicular to EF. Now since they are isosceles triangles, AB equals to AC and DE equals to EF, sorry, DE equals to DF. Because these two sides are equal, AB equal to BC, DE equals to DF. Both are isosceles triangles. I can write AB by AC equals to 1 from this, and DE by DF equals to 1, and both RHS are equal, and I can equate them. AB by AC equals to DE by DF. Now bring this side. AB by DE equals to AB by DE equals to AC by DF, and also given angle vertical angles are equal. That means I can equate angle A equal to angle D. Therefore triangle ABC similar to triangle DEF by SAS criterion. AB by DE equals to AC by DF, that and angles are equal. That means if two sides are proportional to the other two sides of triangle and angle between them also equal by SAS criterion, those two triangles are similar. Now area of triangle ABC by area of triangle DEF equals to AL square by DM square. Since two triangles are similar, we can write the ratio of similar areas of ratio of similar triangles equals to the squares of ratio of the corresponding heights or medians or sides, anything. So a given 16 by 25 equals to AL by DM square, AL square by DM square. Then from this AL by DM equals to square root of 16 by 25, that means 4:5. 4 by 5, 4:5.